welcome back to our lecture series on maneuvering boards. In today's lesson, we will be discussing wind mow boards. We can use a wind mow board if we know our true course and we know what relative winds are relative to our vessel to determine what true winds are. We can also, then knowing what true winds are, determine what course and speed we could drive to get desired winds. Real-world applications of this are typically for conducting flight operations. In the Navy, for example, on a destroyer, if we were trying to land a helicopter, they have very specific parameters for wind requirements. And we can use this maneuvering board in order to determine the best course and the best speed to give that helicopter the best wind for recovery. Wind mow boards are relatively easy. However, it is somewhat of a perishable skill. In the real world, we have many systems on board that we can use which automatically determine best course and best speed to drive in order to give us the best winds. So this is one of those mow boards I recommend practicing often, just so you don't lose the knowledge of how to conduct this mow board in case your systems go down. All right, so we're going to go ahead and start through a practice problem right now. We're going to assume we're on course 240 at 18 knots. We'll go ahead and plot that. Use our 5-to-1 scale for speed. We're on course 240 at 18 knots. We'll draw our vector. And as always, we will label. Center is E, tip of our vector is R. So in this case, we do know what the relative winds are. The relative winds are 040 degrees relative at 30 knots. All right, so this is going to be relative to our position. So we're not looking at 040 true, 040 relative. So that's going to be starboard from our position. Because each one of these is by 10, you just go ahead and count. 10, 20, 30, 40. Winds are at 30 knots. 30 knots will fall right on the 6 range ring. Remember, speed is on the 5-to-1 scale. Now this point right here for the relative winds, we're going to label it A. The A stands for the apparent winds. The next point is to connect our vector to the A. This is called the raw vector. Just easy to remember because it's a funny sounding name. With wind mow boards using the raw vector. And then, like we do with other mow boards, we're going to parallel this to the center. Make our tick mark. And that will give us true winds coming from 315 degrees true. Now in order to find what this true speed is of that wind, we take our compass and we just measure the distance between R and A. Bring it down to the 5-to-1 scale. 20 knots. And that is the solution. True winds are from 315 degrees true at 20 knots. All right, we're going to go ahead and do one more practice problem. I'm going to use the same mow board now, just as save some paper. We are on course 040 true at 15 knots. 040, 15 knots. 15 will fall right on the 3 ring. We'll make our vector. Label it R. Our wind indicator is displaying that relative winds are from 012 degrees true at 11 knots. 012 degrees relative. That's at the 5-2. 052, and 11 knots. 5-to-1 scale for 11 knots. And we plot 052 at 11 knots. Label this point A, apparent winds. Make our raw vector. Parallel it over. Make our tick mark. We have true winds coming from 195 degrees true at a speed of 5.5 knots. When talking about wind, remember, wind is from, seas are to. Wind is coming from 195 degrees true at 5.5 knots. And that is how you solve for true winds. All right, so now that we've discussed how to find true wind, we'll now apply that knowledge to find what course and speed we must drive in order to obtain desired winds. Like I mentioned earlier, we usually use desired wind mowboards when conducting flight operations, either launching or recovering helicopters while at sea. Just as a training point when I'm driving the ship, if we're conducting flight operations, I generally like to find true winds and come about 15 to 30 degrees to starboard from those true winds, slow down to around 10 knots. And that usually gives us relative winds which are within the safe operating envelope for helicopters that we are working with. However, the maneuvering board for wind, desired winds, will give us an exact course and exact speed we can drive for very specific relative wind parameters. So in this problem, we're going to assume we already completed the first step of the mowboard, and we determined that true wind is from 140 degrees true at 20 knots. All right, so for this step, we go over to 140 degrees true, and we're going to draw a line from the center to the edge of the compass rose along 140. What I'd like to do now at this point, just for a visual reference, is to draw our ship. And if it helps, you can label port and starboard. So the CEO told us that he wants winds to be 30 degrees off the port bow at 25 knots. So 30 degrees off the port bow. We're going to look at our little ship. Port is this way. We're going to come over 30 degrees, which brings us to 170 degrees true. And he wants 25 knots. That'll fall right on the 5 ring. We're going to label this point D for desired winds. We mentioned earlier that the wind was 140 degrees true at 20 knots. We're now going to take our compass, calibrate 20 knots on the 5-to-1 scale. Place the pointy end on the D. And then we're going to make tick marks on one side of this line that we just drew, the true wind line, and the other side. And we're going to label where it intersects. We're not label, we're going to mark where it intersects. So now what we're going to do is take our slide rule and connect the dot we just drew to the D. By this point, you probably know we already have to slide this over to the center. We can go ahead and make a tick mark. And this tick mark falls on 282 degrees true. We'll explain what that means in a moment. We're just going to do the same thing for this other line and point. Connect the dot from the line to desired winds. That's important you do it in that order. From the true wind line to desired winds. Bring it over to the center. And this falls on 178 degrees true. All right. So we have these two headings, 282 degrees true, 178 degrees true, 178, 282. This point right here is going to give us a low speed solution. That essentially means if we wanted true winds from 30 degrees off the port bow at 25 knots, we could either drive really fast and make our own winds, or we could use the true wind conditions in order to obtain that relative wind. That's what the low wind solution, low speed wind solution is generally going to give us. In order to figure out how fast we'd have to drive on a course of 178, we just measure the distance between the center and that point. Put on the 5-to-1 scale. We get a speed of 7 knots. So our low speed solution is to drive on a course of 178 degrees true at 7 knots. And we do the same thing for a high speed solution. Figure out the distance between the center and this point. Put it on the 5-to-1 scale. And we get a high speed solution of 282 degrees true at 37 knots. Obviously, one of these is a little bit more realistic to obtain than the other. All right, we're going to go ahead and do one more practice problem for finding desired winds. And in this problem, the true wind is from 220 degrees true at 15 knots. Remember, wind is from, seas are to. We're going to draw our line from the center to the edge of the compass rose on bearing 220. This is our true wind line. We can draw our ship and label port and starboard. So in this problem, the commanding officer wants to place the desired winds 20 degrees off the starboard bow at 25 knots. So in this case, it's on the starboard bow, so we're going to work this way around the compass rose. 20 degrees, you have 10, 20, it's going to fall on bearing 200, and they want 25 knots, which will fall right on the 5 range ring. And we label this point D for desired winds. The problem gives us that the true winds are from 220 degrees true, and we were also given that the true winds are at 15 knots. We'll use our compass, calibrate 15 knots on the 5-to-1 scale, put the pointy end on the D, and make the tick marks on the true speed line. Make these points. And this will eventually be our low speed solution, and this will eventually be our high speed solution. We'll now take our slide rule and find the low speed solution first. Remember, you're drawing from the true speed line to the D. Connect the 2 points. Slide the ruler to the center. We make our tick mark. We have a course of 187 degrees true. Do the same for the high speed from the true speed line to the D. slide over to the center. And in this case, we get a heading of 074 degrees true. And now we need to solve for the speed for low speed and the speed for high speed. We can also go ahead and label this one just so we don't forget, 074 degrees true. And this one was 187 degrees true. This is our low speed and high speed. In order to find the speed, we take our compass and we get the distance between the center and the point. And for a low speed, we get 11 knots. And for a high speed, we get 36 knots. And that is how you do desired wind boards. Good luck.